Okay, question 5. So I've had to research this a little bit because it doesn't come up in the statistics A level. But what I've learned is that confidence level, if something's normally distributed, and we're saying the 95%, we're looking at the values in here, summing to that 95%. And if we put this to a normal distribution where the mean is 0, and then the variance is, the standard deviation is 1, that there, actually, that would mean the variance is 1 as well, because if you square 1, you get 1. This value here is what we're looking at. And if we put that into our calculators, I got quite an inaccurate answer, I suppose. It wasn't inaccurate, it's a super accurate answer. It was 1.95996398, so 1.96 and negative 1.96. And I guess people get taught that quite early on within core maths. I've not taught 2A before, but I reckon they're taught that is 1.96 and they need to know what that is. And then we're going to plug that into the formula. So we need to have the x bar. This is what the confidence interval is going to equal. So x bar plus or minus that z value, which we've just found, multiplied by s over root n. So we need to work out what the mean is first. So we're going to sum all of the values that we've got there, which I should have done beforehand, but I haven't. So 210 plus 308, 308, not 3.8, 312, 195, 265, 251, 215, 224, 262, then hit equals, and then carry on. 294, 190, 233, 320, 196, 240, 271, 320, 245. So that makes 4,551 divided by 18. If you struggle with this work, that's 252.83 with a dot on top of the 3. If you struggle with this work, just work out the mean immediately. That's worth 1 mark. And then at least you can gather something from this question. Okay, so x bar 252.83 with a dot on top, plus or minus the 1.96 multiplied by, the s is the standard deviation. We've got a variance that's going to be the square root of 1750 over the square root of 18, which is our sample size. Okay. So I'm just going to do the plus root, and I'm going to put that into my calculator in one go. So add, open bracket, 1.96 times by, use the fraction symbol, root 1750, and then root 18 below it. Close that bracket, and we get 272.159194, and I'll shorten that to 272. Oh god, I've wrote 7 twice. 272.16, and then the subtract one. Go into this and just remove the answer bit, and the take away bit apparently. 252.8, and there is a recurring button. 3, take away that mess. And that gives us 233.50747727. So that confidence interval is going to be between 272.16 and 233.51. So effectively what you found is that is where we believe, having taken a sample of the mean, that's where we think the mean lies between. So that confidence level is saying that our mean is definitely in between those two values. Okay, so I'm happy with that. Okay, the students on the business course claim that the mean of the average sales of the sweet shop in similar sized colleges is £250 a week. So, comment on this claim. Well, that is within our confidence area. So I'm happy to suggest that that's fine. Let me just double check with the mark scheme. Well, that's a very basic mark scheme. I was just wondering where that second mark's from. So you just put here 250 is within the confidence interval. Which is your first mark. And then they are correct. I just want to double check that mark scheme, that is the second mark for it. Yes or correct. And then alternatively, if you've messed up your confidence interval in the previous bit, you get follow-through marks. So you could put 250 is not within the confidence interval, and therefore they are incorrect, and score 2 marks, so fully correct for 5B, if you've got 5A incorrect. Right, okay, I'll see you at question 6. Good luck, and see you next time.